Hello! Today I figured we would talk about commands. How to make them in Tauri. We're not gonna go into the very deep aspects of it. We're gonna be looking mainly through the documentation that already exists. And it's not gonna be groundbreaking, but I'll show you how to set up commands and talk a little bit about them. Things like how to make an asynchronous command and why probably always your commands should be asynchronous. And without further ado, let's get into it. So here we are on the Towery website, and we're looking at the command calling Rust from the front end feature. So to start us off, calling Rust from the front end. Tauri provides a simple yet powerful command system for calling Rust functions from your web app. Commands can accept arguments and return values. They can also return errors and be async. Basic example. Commands are defined in your source Tauri source main rs file. To create a command, just add a function and annotate it with Tauri command. I've prepared a small application, Nuxt based, to show off how to do this. So the first thing we need is to create the command. And as you can see, this is just a regular Rust function that we have decorated with Tauri command. The most important thing that I have seen a lot of people forget doing is add it to Invoke Handler. It's kind of annoying that you have to do this. I'm hoping we can figure out a better way of doing this, but I don't think we can due to language limitations. And so yeah, you have to invoke handler, Tauri generate handler, and then your function. This will ensure that this function has now been registered in the Towery app. Let's continue. Now you can invoke the command from JS code. And here's two versions of importing it. This is another thing that I've seen a fair number of people confuse. I'm not sure if we should write it quite like this. This should probably be two separate code blocks to make it clearer. But basically, this is a version if you use a bundler. This is a version if you don't use a bundler. And if you don't know what a bundler is, it's, for example, Vite or Webpack. And those really are the only two big options out there. If you're using something else, like Sycamore and the Rust templates, you may have to do it a little bit differently. But let's add the JS API to our project. So what we're gonna do is pnpm add at Towery apps /API. If you don't use pnpm, but use npm or yarn, it's still the same thing that you would run. This should be just, yeah, dist folder. If you ever see that error, just create the dist folder and it should stop complaining. Yep. And now it's telling us to import invoke. So we're just gonna go ahead and enter our app.view. And we're going to make this very simple. This is our app running. If we just do script, we import invoke from Towery apps API /Towery. Then we do export default, and this is just Nuxt /view lingo. You don't have to worry too much about it. Mounted is just a function that runs when this component gets mounted. So when it's visible, basically. And we're just gonna run invoke my, what was it called again? My custom command. If we now open our app, we should be able to refresh this, and you can see that I was invoked from JS. And that is indeed the print line statement that we had. And it will appear in your terminal, which is yet another thing that some people have been confused about. Sometimes people think that it should appear in console log, but if you do a print line statement in Rust, it will appear in the terminal, because you are actually running it in the native end. The next thing we're going to look at, actually, let's just make a small comment about this. When using the Towery global script, if not using the npm package, be sure to set build with global Towery in Towery conf JSON to true. So this is only if you are in Towery, you have Towery conf JSON. Here, there's a with global Towery. This by default is false. And that's because there are some minor security concerns with using global Towery like this. It's not a huge deal, but it's false by default for a reason. Let's just put it like that. You can use it, that's why it's an option, but the better option is that it's false and disabled by default. If you don't use npm, if you use the vanilla template, for example, without using Vite, then this is how you would get it if you use a CDN version. But let's continue. Passing arguments. Your command handlers can take arguments. Towery command function invoke message. So let's replace our function with what we have here. So what we've added now is just a basic invoke message argument, and we're printing I was invoked from JS with the message and then the message. And indeed, if we open our app and we just refresh a bit, we can see that nothing was passed, because now we need the argument. So if we do this here, it should be invoke message hello world. If we now refresh this, I was invoked from JS with the message hello world. Each time I refresh, we invoke the command and it prints hello world. Nice. Let's continue. Actually, first a small comment on this part. So you can see that we're using snake case. No, wait, I mean Pascal case. Oh well, whatever. We're using the whatever it's called when you're using it in JavaScript in order to make it more ergonomic for JavaScript developers. So JavaScript developers would usually put it in this way, but in the Rust end, our arguments are called using snake case, because in Rust we prefer this style, basically. And so we have invoke message with the underscore, or we have with Pascal case, or whatever it's called. Camel case, that's what it's called. There's a difference between them. I think it's camel case when it's small first, and Pascal case is capital first. Anyway, arguments can be of any type as long as they implement third deserialize. This part is important if you are making custom return values of any kind that there isn't a standard implementation of third deserialize for. So if we want to return something from this, here, by the way, they have added, please note we are declaring arguments in Rust with snake case, the arguments in camel case for JavaScript. To use snake case in JavaScript, you need to declare it in the Tauri command. So rename all equals snake case. If we do this, we can now instead invoke it as invoke. We can invoke it like that instead, so it looks more like what you're used to in Rust. So this is really just a matter of taste. Neither is better, technically. The default here is just to put it like this, because that's how most JavaScript will want it. If you run something like ESLint, you could have projects that don't allow you to use snake case, and they will complain about it. And then you have to change the ESLint options and stuff like that. But this string can always be snake case, which is why the default is the way it is. And I do think that's the better alternative. Returning data. So if we have a return value for this, which in Rust is as simple as specifying it as like so, and then we can from Rust into. Now, if you run into like this, it basically tries to convert this value into a string for you. And this is no different in this case from running it like this. So into is just an easier way to add something that is somewhat close to polymorphism into Rust. But yeah, here you're just converting it into a string. Into also just creates a string from it. And if we now open up our project again and go here, we can do const return message equals. Here's an important part. The invoke command returns a promise, and it always returns a promise regardless of whether or not your command is async or not. So if you invoke this, this won't be the message. So let's console log return message. And this time the message will of course appear in console log because we're logging it in the front end, and the promise is what's being printed. And that's because we have to resolve this. If you're not used to async programming, because you can use promise-based programming as well in JavaScript. If you're not used to async, get used to it. It's better once you get used to it, and it doesn't really make much of a difference in terms of what you write. Let's see. During message for command. We didn't rename the command, did we? No, but I did remove that part. So let's just remove this. And we'll stick to what I think is better. And there you can see hello from Rust. And if you aren't using async, if you have to put it in a synchronous block, what you can do is remove async. This is now a promise. And if we use promise-based programming for this, we would do then return message. And this is now a promise-based setup. There's not that much difference between them. And really, async just allows you to use await instead, so that you can do something that looks like this. And it might take a while for people to grasp it. It took me a little while to grasp just how to efficiently develop in TypeScript with async and await. Because for some reason you kind of start to assume that, oh, but doesn't this just mean that we're running an async function but turning it into a synchronous function? And that's not quite what we're doing. What you can do is to for example. This is just a very basic example, but all of these will now be started at the same time. And if we now await these, we can start to... That, by the way, is not the way to do it properly. If you do promises equal no, we can do this. In a const let I plus I is less than 15. Promises push await promise all promises. Now if we check this out, we should see that there's no output, but we can do const return values, console log return values. Doesn't return anything. Promises push. It's so long since I made a for loop like this in JavaScript, but isn't that for loop? Like a total noob, I'm just gonna look it up. Yeah, it is the proper syntax. Oh, right, I have to initialize it. There we go. Okay, now it's better. Yeah. So now we can see here that the return value we get is an array with all of these, and all of these ran asynchronously because we started them all at the same time, or, you know, we kept just starting them up and we're not awaiting them until after. So this is how I would write it if you need to run a lot of things in parallel in TypeScript. That was a little bit of a sidetrack, going more into just how async programming works in TypeScript, but I've seen a lot of people struggling with this, so I just figured I would take the opportunity to mention it. Because as you can see here, they suggest using then, but you can use async instead. It's much better, or much nicer at least. Return data can be of any type as long as it implements Deserialize. And so arguments have to be deserialize, return values have to be serialize, and that's because of how Towery communicates over the IPC. So the inter-process communication with the web view and Towery works by turning values into JSON values back and forth. So if you want to send a value from the front end to Towery, you have to be able to deserialize it. And if you want to return it, you have to be able to serialize it. And deserialization is essentially turning the JSON string into whatever value you have or that you want in the Rust end. And serializing is about turning the value in Rust back into something like a JSON string. Error handling. If your handler could fail and need to be able to return an error, you have the function return a result. And we're just gonna do this. We're gonna do this, we're gonna do wait. So we only call that once. And then we're just gonna go ahead and copy what they have. So now we should always be returning an error because of how I wrote it. I don't like the fact that this isn't copy-paste friendly. In the sense that this should be a slightly more complete example. Like, I get it, it is nice, but it shows what should be done, but this is for the beginners, and the beginners don't necessarily know that why this would fail. So here we're returning it as an error, and we get an error in JavaScript, which hasn't been handled. So we would then have to add a try catch e console error e. And what we should see now is this failed, which is the actual message that we sent from Rust. This failed, this failed. And if we just remove this part, we should be seeing that it worked. Or, well, we didn't print that. Console log. There we go. This worked. Yay. So that's how you would set up error handling for your command. If the command returns an error, it will be rejected, otherwise it resolves. This is the promise-based version, but you're a good person. You're not going to use promise-based programming. You're going to use async programming. But this is what it would look like in the async or in the promise-based development. Note that this is very easy to forget to add to all places where you use promises, which is another reason why I prefer async programming, because you saw that we got a proper error, even though I didn't add any promise handling. With this style, if we don't add this line, I might never know that anything went wrong. So async programming for the win. As mentioned above, everything returned from command must implement serialize, including errors. This can be problematic if you're working with error types from Rust's std library or external crates, as most error types do not implement it. In simple scenarios, you can use MapError to convert these errors to strings. So this one tries to open a file that does not exist, and if it fails, you can map the error to a string. Okay, return nothing on success. And the point of this is, just as it said, sometimes when you work with random crates you find on crates.io, the error they have doesn't implement serialize, which, as we said, was what was needed to go from Rust into the front end. If they don't implement it, it can't be sent. So by doing this, we're turning it into a string. And if we send string values, we're capable of serializing it easily. And this should indeed no such file or directory or OS error 2. So this is a simple way of turning a non-compatible error into a compatible error. This is not very idiomatic. You may want to create your own error type which implements serialize. In the following example, we can use the ThisError Crate to help create the error type. It allows you to turn enums into error types by deriving the ThisError trait. You can consult its documentation for more details. I'm not going to go over this in detail partially because I don't feel like adding this error, but actually, because I've seen enough people struggle with it, let's just copy paste this. And what people have been struggling with that I've noticed is they don't know how to add things from crates.io. And in this case, what we're adding is not cargo commander, which I'm entering now, which is my project, by the way. So shameless self-promotion. We're adding this error, which is this crate. Any crates you find on crates.io can be added to your project. And all you have to do, literally all you have to do, is this part, which you can always find on the side, easy to copy paste from here. Just like that. And there's nothing else you have to do, no downloads to do or anything. I personally tend to use an equal sign before, because if you don't have the equal sign, you get it automatically updates your major and or minor and patch versions according to semver customs, but a lot of crates don't properly handle semver. It's like this kind of thing where it's nice in theory, but in practice, so many people don't properly use semver. So add an equal sign before and you'll get exactly this version. If I just do this, if this error comes out with 125, I would get 125. Now I will always have 1040. So this is the syntax that I prefer, and you should too. But now that we have this error, the errors we had in here with this failed, or not failed, they disappeared. So let's open the app again, and no such file or directory. Nice, because I'm assuming, yeah, they're doing the same thing. And the part they talked about it not being very idiomatic is because now you can see how nice your command looks from what it looked like before. Before, we had something where you have to map it, and it just doesn't look very nice. Now you can just set up this little bit, and you get an actual compatible error. That's nice, and it's something you should probably do for more serious things, but they both work. They both do essentially the same thing. And a custom error type has the advantage of making all possible errors explicit, so readers can quickly identify what errors can happen. This saves other people and yourself enormous amounts of time when reviewing and refactoring code later. It also gives you full control over the way your error type gets serialized. In the above example, we simply return the error message as a string, but you can assign each error a code similar to C. This way you could easily map it to similar looking TypeScript error enums, for example. And yeah, this is all valid. And if you have a serious project, you should probably set up proper error handling with custom errors. Asynchronous functions are beneficial in Towery to perform heavy work in a manner that doesn't result in UI freezes and slowdowns. Async commands are executed in a separate thread using async runtime spawn. Commands without the async keyword are executed on the main thread unless defined with Towery command async. If your command needs to be ran asynchronously, simply declare it as async. Caution, you need to be careful when creating asynchronous functions using Towery. Currently, you cannot simply include borrowed arguments in the signature of the asynchronous function. Some common examples of types like this are @string and state, whatever. This limitation is tracked here, and workarounds are shown below. So let's start by backing up a bit so we get a slightly simpler function to work with. And all we're gonna do now, literally all we're gonna do, is write async. Just like that. Good job, you are now an asynchronous programmer. You know how to do it. You just added the async function. In the backend, what happens is that Tauri uses Tok.io, or Tokyo, as some people say, which is a runtime for Rust that starts up a bunch of threads basically in the background. And whenever you run an asynchronous function, Tok.io will handle a bunch of threads and handle passing that function to the threads in order to concurrently run these. Not in parallel, but concurrently run all of these functions. In theory, like technically, they're not running in parallel, they're running cooperatively, which is something that we'll have to look at another time in a more dedicated video for asynchronous programming. But essentially, just be aware of Tok.io handles it. It's a runtime that handles a bunch of threads, and it allows you to do asynchronous programming. So this will now execute on its own thread, or cooperatively with a bunch of other stuff on threads. This makes sure that Tauri can manage the web view and have its main loop run without issues. So in like 99% of cases, add async because it'll help performance. It won't always make a noticeable difference, but it'll be theoretically better in most cases, and yeah, use it whenever possible. They talk about limitations with it, and this is valid. It's just unless you encounter one of the limitations, just keep adding async. When working with borrowed types, you have to make additional changes. These are your two main options. Option 1, convert the type, such as at string or borrow string, to a similar type that is not borrowed, such as string. This may not work for all types, for example, state data. For example, we accept value string, and then call another async function and wait for it to finish. Format value. And so yeah, basically just use string instead. A lot of times borrowing a string is better for performance purposes, but also in most cases the difference is so small that you don't have to care about it. The big difference is whether it's stack or heap allocated, which is something else that we won't go over today, exactly what that means. But essentially, it means whether it gets put in a place in your software that is handled at compile time and is far more performant, and or if it gets put in the heap, which is a more dynamic piece of memory. Putting it on the heap is slower, but most of the time it doesn't make much of a difference. If that is the difference in performance, you're either A, doing something that involves looping and something extremely intensive like AI development, for example, or you are putting something very, very big on the heap that probably couldn't have been put on the stack anyway. But regardless, this is one way of solving borrowing string. Wrap the return type in a result. This one is a bit harder to implement, but should work for all types. Use the return type result AB, replacing A with the type you wish to return, or void if you wish to return nothing, and replacing B with the error type to return if something goes wrong, or void if you wish to have no optional error returned. For example, result string void to return a string and no error. Result void void to return nothing. Result boolean error to return a boolean or an error as shown in the error handling section. Example, return a result string void to bypass the borrowing issue. So here, what's happening, as far as I can tell, is exactly, it's being wrapped in OK. And it's turned into a string. So, yeah. I'm not sure why this fixes anything or exactly what it's supposed to fix, because presumably they should have been talking about how to fix the state issue. But regardless, this is another alternative for fixing the return value. And usually with asynchronous programming in particular, but just usually in general, any function you make should return a result. Now, it's not necessary for every single function that exists, of course, but at least for your commands that you make, they should generally return a result, and you should assume that your function can fail for some reason, so that you have to set up proper handling in your front end. And just in general, in Rust, I tend to try to always return results rather than direct values. Now, you can, of course, return direct values if you have something that's just a transformative operation. Say you're just turning one string into something else, or something like that, and it can never fail for whatever reason. Then if it can't fail, it's fine to not return a result. But results tend to be the better way of handling things. Just it can prevent issues, is basically all I'm gonna say. And this is just invoking it again and then handling it. Accessing the window in commands. Commands can access the window instance that invoked the message. This is a bit of an automatic handling on the Towery's end. It's a little bit of magic, but you can just, if you want to get a handle to the window that invoked this command. So say I have this window and I'm invoking a command, and in that command I want to handle the window itself, the Tauri window. All you have to do is add this, and now you have a handle to that window, and you can do things with it. As you can see, like you can center it, for example, or you can what else do we have? We have maximize. We can run that, I think, at least, because we're running in VSL. Yeah, that made the window disappear. That's not awesome. And this is a VSL weirdness about how the windows are handled. If you use my dev container, be aware that there are a bunch of these kind of annoyances with desktop development. I mostly use it because I can still go into maximized view. It's just running a maximized function doesn't seem to work that well. So just be aware that there are limitations to working in the dev container, and this is one of them. But this is how you get a window handle. You can get the label, and as you can see here, printed window main. And if we just refresh this a couple times, we can see that invokes window main. Accessing an app handle in commands. And let's do that. And hopefully they didn't do anything too weird here. Not sure why they would have this as the example. It's a little, just a tiny bit weird. Simply because this, as far as I know, means we're gonna have to add a global shortcut. I'm just gonna say true here. That should be it. There we go. And this presumably has Control U. It's not necessarily the case, by the way, that this works because, again, VSL limitations. And it doesn't seem to work the way I want it to. But it doesn't matter. The point here is this is how you would automatically get an app handle. And for those of you who don't know what an app handle is, an app handle is basically the app, like the main entry point into your app. What's being created by the builder is an app. If you have to access anything in your project, what you need is an app handle. This creates an app, and what you use to communicate with it is an app handle. Essentially, all an app handle is a way of thread safely accessing the main app instance. And you don't want to access an app directly, you want to access an app handle. So if you want to do anything with the app, that's how you do it. And all you have to add is this. With a state, for those of you who don't know what a state is essentially a bit of storage for variables that persist in the app instance rather than in like normally when you run a command, the value disappears when you're done with it. So whatever you do in here goes away. So in order to keep things for the entire run of your app, you would put it inside a state. And all a state is really is any type of struct or value that you want to make available. Like you can make this however you want. This is just an example of a very basic struct. And you can even manipulate the values inside the state by wrapping them in a mutex. Let's start by just seeing what happens when we run this. We don't see any output because this is just assert equals. Yep. So some state value, so this is true. If we do false here instead, it should rebuild and then crash. Yep. It crashed because it went true. So state.0 indeed stores this value, which we put into my state, which is a struct that has that string. Let's say we want to alter that value. What we could do is mutex. Let's see, is it mutex new? Dun, 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 dun. Isn't it? Unwrap. Wait, this should be string. Oh wait, it's because we're that's it, right? I do. Ugh. See, this is because we decide to use the Tauri version, which I don't really use. Yeah. All right, this should be more like it. npm Tauri dev. As we can see, it didn't crash, but it's not that interesting to look at that, so we're gonna do value.0. Just so that we can actually see what's being stored in there. As you can see, some state value is now stored in there, but after we print it, we're going to do value equals something else. Let's see, what is it again? Isn't it get mut, actually? Get. We're just gonna move on. It's beyond the scope of this specific tutorial how to do it, but I'm just gonna talk you through it instead, because I just plain forgot how to exactly do this quick enough for this video. But basically, mutex is mutable exclusive, which is a thread-safe way of handling mutability in Rust, where you lock the value in order to access it, and once this value goes out of scope, so basically when you reach the end of the function, the lock is removed, meaning that another thread can access the value. And it's also how you would ensure that just one thread can access and alter the value at any given time, so you don't get things like race conditions and values accessing things at the same time. Creating multiple commands. The Tauri generates handle containing an array of macros, or commands, I mean. And all that means is that if we copy paste, Control C doesn't always work for me. This is just wrong. So that needs to be fixed in the documentation, because it doesn't return the proper value. Again, I hate when documentation isn't copy-paste friendly. And all we did was, whenever you have a new command, you have to register it with your app, as I said before. If you don't register it with your app, it won't be available. Lots of people have failed adding their commands to their app, and wondered, why doesn't Invoke work? Well, you have to register it with the app, otherwise it doesn't exist. In a complete example, any or all of the above features can be combined. So here we have an example where they have a database struct that they use as a state, and they create a custom response. They have some function that is asynchronous that they want to run. They have an asynchronous command. They get the database, they get the window, they get an input value, number. The order, by the way, of these don't matter. You can put them in any order. We return a result, print line. Yeah. It's just a more complete example. And that really is it for what we're gonna go over today. So not a whole lot of critique this time for the actual documentation. Most of these things were copy-paste friendly. The biggest no-no in terms of copy-paste friendliness is just this part. This should have into at the end, and specifically into because that's what you used earlier. So you stick to a format. Either that or toString for the sake of showing off multiple ways of doing it, but in the end, what we have here is a lot of information, and this should definitely be broken up into more bite-sized parts. This is why I waited so long with making this video, because, I mean, with a mutex, for example, like, I can get that to work, but I was only prepared for going over what's in the documentation. It doesn't go over how to handle mutability in the state. It's just telling you how to access a state, but we don't actually have a page for the state. So a lot of people don't even know that the state is a thing. I can't tell you how many people I've had to inform that the state is a thing that you can use, and I have to link them here. But this is calling Rust from the front end. Why isn't state handling its own page? Because it's such an important feature. This really is like the best place to go to in order to find examples of how to use Towery, and this is a huge feature. It shouldn't just be baked into some small part. And what is an app handle? How can I interact with it? What can I do with a window? Like, there's some stuff in here about that, but all I'm saying really is we have more work to do when it comes to documenting all the various features of Tauri and giving them their own pages. And that really is all I had to say for today. I hope you liked the video and that it was informative. Have a good one. Bye.